Right, guys, I'm just going to go over the answers to the sound assessment. So at the end, if you can add up all your score and put it here, that would be great here. So the question one, we have to match up the words to the definitions. The amplitude is the distance from the middle of the top of from the middle to the top of the wave. So those of you who forgot what that actually looks like, that is, if I draw a wave out, so that's the middle, that dotted line's the middle, and then that distance there is the amplitude. So from the middle of the wave to the top of the wave, that distance there is the amplitude. Okay, right. The next one, the vacuum, is empty space, no particles. Wavelength, it's the distance from one peak of a wave to the next. So on the same picture, there's a peak, and the distance from there to there is what we call the wavelength. Okay, ultrasound. Ultrasound is a frequency that we can't hear, and it's above 20,000 hertz, and that will be useful later on in the test. And frequency is the number of waves that pass per second. So just imagine water waves and how many waves that pass a particular point in 1 second. Okay, and getting all of those right, 1, 2, 1, 2, 3, 4, 5 will pick you up 2 marks. Okay, if you get one wrong, that means you get 1 mark. If you get 2 wrongs, you get no marks. Right. The next question, question 2, you got to fill in the blanks. So we're going to go to point B. Point B is that point there. That's the auditory nerve. Okay. Part C, that's that bit over there. That's the eardrum. The part D is where the sound travels through before it gets to the eardrum. That's the ear canal. Part E are those small bones that are connected to the eardrum. We call them ossicles. And part F, that there, that snail-like structure, that is where the sound energy is turned into electrical energy that could be then passed through the auditory nerve, and that's the cochlea. Right, that's out of 3 marks. So if you get all 5 correct, that's 3 marks. If you get 1 wrong or 4 correct, that's 2 marks. And if you get 3 correct out of 5, that's 1 mark. And if you get 2 correct or 1 correct, then that's no marks, unfortunately. Question 3. Now, this formatting hasn't turned out the best, but the part A says sound is made by any object that is vibrating. So a drum vibrates, creates sound. A speaker vibrates, creates sound. Your voice box inside your throat vibrates, creates sound. So particles need to vibrate. Okay, and that's what creates sound. Sound waves travel as, or sound travels as a wave. Sound travels fastest in a solid, and sound cannot travel through a vacuum, and each of those is 1 mark each. Okay, now the next part is worth 2 marks, and it's a little difficult to mark this if you've got it wrong, but let's start. The first thing that we are going to do is measure the overhang. So those of you who can't picture what's going on, is imagine you've got the edge of the table there, and you've got your ruler placed on the edge of the table, and it's fastened down, generally with a G-clamp, okay? And then you move the ruler downwards or upwards and let go, and it'll start to vibrate. When that vibrates, it creates sound. So the experiment is, how are we going to get the overhang and the actual pitch, okay, and the pitch. So the way that we are going to do this is first measure the overhang when you haven't moved it. So measure how much the ruler is overhanging the table. Then write that overhang down in the table down here. So that's part C next. Then pull down and let go. So pull down the ruler and let go. That's part A. Then it's part E. Listen to the pitch of the sound, and then record the pitch in the table, whether it's a low pitch, medium pitch, high pitch. Okay, our ears are not sensitive enough to give a value for, let's say, a frequency. So what we can only do for this type of experiment says high pitch, low pitch, medium pitch. So here are some results. Actually, let's go back here and how to grade. So if you get all of this right in the correct order, it's 2 marks. Okay, if you get one of these that are in the wrong place, but all the others are in the right place, then you get 1 mark. Right. Again, formatting, I think they've not been the best. So this table shows this column here is the overhang in centimeters, and this is the pitch. So it says state the relationship. Now all we need to do is look at the numbers and how they are changing and spot a pattern. What's the pattern? The overhang is going down. The pitch is going from low to high. So as the overhang decreases, so we're going from 20 to 15 to 10, that word there is decreases, going down. What happens to the pitch? It goes from low to medium to high, so the pitch is increasing. And that's how you write down your relationship, okay? So what is the pattern? Question 5. Light, as we discussed in lesson, travels faster than sound. So we need to circle faster. That picks you up 1 mark. Okay. People lighting fireworks wear ear defenders. State the role of the ear defenders. Well, it's to protect the eardrum from any damage. Okay. So some of you may have written is protect the ear. You should write from what? Protect the ear from any damage. Okay, right. The next one is explain why sound will travel faster in water than in air. You did an entire presentation on this. So first mark is particles are closer in a liquid than in a gas. This means that collisions will occur faster. So that's your second mark. Collisions will happen quicker. And that would mean that the sound wave will travel through the liquid faster. Okay, so first mark, particles are closer, collisions are quicker, so the sound wave travels through the liquid quicker. Okay, question 6. You can make waves in a slinky that are transverse. Gabriel did this as a demo. We all stood up and we watched the demonstration. Now, this here is the wave that they are discussing. The first point is on the diagram, draw an arrow to show the direction of motion of oscillation of the slinky. So they want to know which way must my hand move to create a wave like this. So my hand should move up and down like that to create a wave like that on the slinky. Okay, so they've asked you in the question to label it oscillations, and you need an arrow with the arrow pointing at both ends outwards. The second part is draw the direction of the wave. So if you're moving your hand up and down on this side of the wave will move to the right. So if when you saw my hand was here, Gabriel's hand was here, and what you saw was the energy was being transferred from my hand all the way to Gabriel's hand. Okay, right. Question 7. Sound waves are reflecting off a surface. So that's what an echo is, reflection of sound, and that must be in your answer, the word reflecting. Okay. Some of you might write the sound waves bounce off. I'll give you the mark for that, but the correct word is the sound waves are reflecting off the walls. That's what an echo is. Here is a graph of different animals and their frequency range. So animal A and frequency range from 0 to something around about 17,500. Animal B to 0 to 20,000. Animal C from 0 to around about 16,500 hertz. D from 0 to 40,000, and E from 0 to around 14,000. So state and explain which animal is not a human. So we know that humans have a maximum hearing range of 20,000 hertz. So we see D, the bar for D goes beyond 20,000 hertz, goes all the way to 40,000. So we know animal D is not a human. That's one mark. And because that's your second mark, the frequency is above 20,000 hertz. Okay, that's your second mark. So it says all other animals are human. The range of frequencies that you can hear decreases as you get older. Stay and explain which is the youngest human. So the younger you are, the greater the frequency range. So out of A, B, C, and E, which are humans, which have the greatest range, so which has the largest bar, it's B, go from 0 all the way to 20,000 hertz. All the others are less than 20,000 hertz. Okay, so 2 marks. So B is the youngest human, 1 mark, because they have the largest frequency range, and that's the second mark. Part C, very loud sounds can cause pain. Suggest and explain why. Okay, loud sounds have more energy. That means that they have higher amplitudes, which can cause the eardrum to vibrate at large amplitudes and causing it to tear. Okay, so suggest a reason why loud sounds have more energy, high amplitudes, explaining that how does that cause then damage to the ear. That causes the eardrum to vibrate with large amplitudes, and that could cause a tear. And that's your second